Welcome to the Missing Data Imputation course. This is the very first course I have ever created, and it's a free course, so please leave your feedback. For more stuff, you can check my YouTube channel, which is Aero Developing. I hope you enjoy the tutorials, the free tutorials there as well. You can also check my Udemy profile for other courses that I may have created. And let's move on to the missing data imputation problem. So first of all, we're going to discuss why this is a problem. And there are various reasons why missing data are a problem. A lot of machine learning algorithms rely on complete datasets. Complete datasets mean that they have no missing values. Actually, a lot of imputation methods actually rely on complete datasets. So in order to run complex imputation methods, you need to do a very simple imputation in order for them to run, which is absolutely crazy. So, if you have a random forest or XGBoost or SVMs or linear and logistic regression, you may be unable to run these methods if your data have missing values. And please never drop samples or features with missing values. You essentially do biased analysis and drop important information. Second of all, different types of missing data, and we will see the three types of missing data really soon, may require different imputation methods for accurate imputation and maximization of performance. This is very important. Third, the field of missing data has been mostly studied by statisticians. Lately, in the last 2 to 3 years, a lot of scientists, ML scientists and deep learning scientists have jumped into the topic. However, a lot of the methods proposed are not actually a lot better than the statistician one-based. And also the literature reports contradicting results because it measures different types of things. So, one of the benchmarks for imputation and also finding what works in the real world is checking what AutoML tools done. So imputation in the machine learning pipeline and in general the automated machine learning pipeline fits into a very specific spot. After scaling the feature values, you want to do imputation. Imputation needs to be done before feature selection and model selection. Why? Because as we have said in the previous slide, feature selection, model selection, feature extraction usually cannot be run. Models cannot be fit on the data if you have missing values. But why does imputation need to be done after scaling of the features and removing constants? This happens because a lot of imputation methods also work within a range of values. We will see that the deep learning methods that I have proposed, we will learn need to be in a specific value range, usually 0 to 1. And also, some dimensionality reduction methods that we are going to see also need to be in this value range. Finally, imputation methods have hyperparameters, so you need to optimize also the imputation stage using hyperparameter optimization. And we will also see how you will be able to tune those imputation methods and sensible values and hyperparameters to check and test. So let's see what the imputation methods what the AutoML tools currently use for imputation. The majority of AutoML tools rely on simple imputation methods such as min-mode imputation. For example, JetBio, Teapot, AutoGluon, and AutoScikit-learn use min imputation and mode imputation or some variation of these. For example, Teapot and AutoScikit-learn use median imputation, whereas AutoGluon uses for categorical features the new category method, which essentially what it does, it creates a new category named missing. Autoprognosis also uses simple imputation methods and complex ones like dimensionality reduction method soft impute, iterative methods like misforest, and also other methods. And what it does is it optimizes over all those imputation methods in a cache perspective. So what it does, it has a lot of imputation methods here, the hyperparameters, and it does HPO over them. So let's continue with the missingness mechanisms. There are three very important missingness mechanisms, and please pay attention to this slide because it's really, really important. The first missingness mechanism is missing completely at random, and it's called mcar. For missing completely at random data, missing values do not depend on the data. Let's see an example. For example, you have a dataset that got corrupted, meaning it lost some of its values when compressed. This is completely random. It does not depend on the data. It's a completely random event. So what essentially this means is that your missing values are missing with a probability p independently of the data. Then you have missing at random. Missing values are related to the other observed variables. What does this mean? For example, let's say that you have two features, income and taxes. What missing at random assumption makes is that people with higher income may not have answered how much taxes they pay. So, when you go to higher income values, you may find a lot of more missing values on the taxes feature. So this is missing at random. Missing values are related to another observed variable. You have captured the variable income. If your variable income was not in your data and you only had taxes, then it would be missing not at random, meaning missing values are related to the values of the variable itself or other latent variables, meaning unobserved variables. So this is the same example. People with higher income may refuse not to answer how much money they make. So if you had an income feature and people with high income may have missing values. People with lower, so you won't be able to do an accurate estimation of the missing values using this way because you have no information. And again, the three missingness mechanisms are all assumptions. The only missingness mechanism that you can prove is the missing completely at random. Finally, let's see what imputation families exist. First of all, you have methods that rely on one feature at a time and methods that rely on multiple features to conduct imputation. So, the univariate family conducts imputation on each feature independently of the other features in your data. This family contains mean, mode imputation, median imputation, max imputation methods. On the other hand, multivariate methods can be split into two families, iterative ones and distance-based methods. Distance-based methods rely on a distance function. For example, KNN and K-means rely on a distance function to conduct imputations, and these methods are usually sample-based. Iterative methods can be again split into two subfamilies, discriminative and generative. The discriminative family can again be split into two branches, linear and non-linear. Linear methods, for example, linear methods is mice, which relies on linear models that you build on each missing feature to predict the missing values. Whereas non-linear is misforest, which relies on random forest, which is a non-linear machine learning based method, and maybe DataWig, which uses a deep learning method for each missing feature. We will see more later on. If you have not understood what I have said, please be a little bit patient till we go to the misforest module. Then we have generative methods, which we can split into two methods again. Matrix factorization, matrix completion methods, which are linear dimensionality reduction methods, and neural network-based ones, which is, of course, nonlinear. So matrix factorization contains dimensionality reduction methods based on probabilistic PCA, and singular value decomposition. Soft impute, BPCA, PPCA. Spoiler alert, these methods try to capture the joint distribution using linear methods, and they do not work very well. Then we have neural networks, which are nonlinear methods, as stated before, which try to capture the distribution using neural networks. You have GANs, or else called GAIN, which is generative adversarial networks for imputation. You have DAE, which is the denoise autoencoders, variational autoencoders, and AIMNet, which is a transformer architecture. I hope this was a very good introduction to the problem. This was a summarization of months of literature review. And again, if you have any questions, you can drop them down below. And in the next modules, we will go through for the imputation method specifically and how to optimize them.